So something that's going to become really important in this section is just that we know for every one of these ordered pairs around the unit circle that the x is cosine of that angle and that the y is sine of that angle. And then we're going to have to understand that in every quadrant, if we're looking at quadrant 1, they're both positive. If we're looking at quadrant 2, we've got cosine is negative, but sine is still positive. In the third quadrant, they're both negative. And then in the fourth quadrant, we've got cosine being positive and our sine being negative. So just being able to very quickly say, okay, if my cosine is positive, I have to be in the first or the fourth quadrant because that's where x is positive. If we're talking about sine being negative, automatically knowing that's below the x-axis in the third or the fourth quadrant. So a way that people memorize these, which I feel like as long as you know that cosine is x and sine is y, then you should be able to reason through it. But some people do use all students take calculus, which is just an acronym to help you with which function is going to be positive. So in the first quadrant, all of them are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive, and this is just talking about sine, cosine, and tangent, by the way. And then in the fourth quadrant, only cosine is positive. So if you have to use that, the all students take calculus, that's a helpful tool, but as long as we know that this is our x and this is our y, we should be able to reason through any of the sign differences. So for each one of these, we're just looking at having some different conditions. Maybe they'll tell us what quadrant it's in. Maybe they'll tell us that another function is positive or negative, something like that, to give us a hint for where this angle is at, which is going to help us find whatever we're finding. So in the first example, they give us tangent of theta, and that's going to help us set up a triangle. But then we also know that sine of theta is less than 0. So we can reason through this a little bit. Just the fact they're telling us that sine of theta is less than 0, they're telling us that sine is negative. Okay, we also know that tangent is negative. So when we're kind of thinking through this on our unit circle and deciding which quadrant we're going to be in, if sine is negative, that means I have to be below the x-axis, so I'm talking third or fourth quadrant. But if tangent is also negative, it's not going to happen here because negative divided by negative is going to be positive for tangent. So I have to be in the fourth quadrant. So by giving me this information, that tells me when I draw this that I'm in the fourth quadrant. So I've got, and our triangle doesn't necessarily have to be to scale, just make sure it's in the right quadrant, and I think you're good from there. Since our tangent of theta is this 15 over 8, I've got my opposite over adjacent is 15 over 8. And what's going to help us in this quadrant, knowing where it's at, is knowing where to apply that negative. And if I'm in the fourth quadrant, that means that my y had to be the negative piece of this. And they also told me that sine was less than 0, so kind of both of those things. But that could be important for when we find cosine. If it happened to be the negative part of this, then that would be important. From here, I'm going to work this out just like I did my right triangle trig. In order to find cosine, I do need to figure out my hypotenuse, so go ahead and use Pythagorean theorem. Figure out what your hypotenuse is. Okay, and we should get that our hypotenuse is 17. So we've got the 17 over here for the hypotenuse. So then our last step is just applying this to whatever trig function they're asking us to find, and possibly they're wanting us to find all 6, which we already have really tangent and cotangent, so we've got 4 left. But to find cosine, we've got our adjacent over hypotenuse. And we can be sure that it's not going to be negative because we're in the fourth quadrant, so cosine has to be positive, the x is positive, and then our hypotenuse is always going to be positive as well. So for example 2, we don't have any conditions here. They just tell us what theta is. So we're finding sine, cosine, and tangent. They don't want us to use a calculator, and I'm going to say anything from here on out that is something that you could get from the unit circle. Try not to use a calculator for it. Try not to use your unit circle either. It may take a little bit of work to figure out this 5 pi over 3. It's not necessarily one that you have memorized that you can answer really quickly, but we can use things that we've memorized to answer it. So try not to use a calculator. We've got this theta equals 5 pi over 3. So first, I'm going to need to know where this 5 pi over 3 is on my coordinate plane. We're thinking through the fact that this 5/3, where it is in between 0 and 2, remember that goes to 2 pi. And my 5/3 is in between 1.5 and 2, so I'm landing somewhere in here, still in the 4th quadrant. And then I would need to know that my reference angle right here, because I have that 5 pi over 3 where it's going to land, it's going to have that pi over 3 reference angle. So I just end up with that same reference angle as what my denominator is there, that pi over 3. So from here, it's important that I have the unit circle first quadrant stuff memorized for pi over 3. That way I can apply it to what I'm talking about here sine-wise. Because I know for sine of pi over 3, I'm going to go ahead and write each one of these, and then we'll go to 5 pi over 3. So my sine of pi over 3 is radical 3 over 2. My cosine of pi over 3 is 1/2, so that's the part that I should have memorized. For tangent of pi over 3, if I don't know it, I can go ahead and divide my radical 3 over 2 divided by 1/2 or multiplied by 2. And I'm going to get radical 3 for my tangent. So then the only difference here between my pi over 3 and this 5 pi over 3 is the fact that I'm in a different quadrant. So I may have things that are positive or negative depending on where they're at. And we know in this 4th quadrant that sine is negative, but cosine is positive because we're talking about that x value and y value. My hypotenuse is always positive, so that means that my tangent is going to end up being negative because I'm dividing opposite over adjacent. So just kind of thinking through my sine and cosine positions, my sine of 5 pi over 3 is going to be a negative radical 3 over 2. My cosine of 5 pi over 3 is going to be a positive 1/2. And then tangent of 5 pi over 3 is going to be a negative radical 3. So very important that we knew where this was occurring, because if I just went with my pi over 3 reference angle, I would be wrong on 2 of these because 2 of them ended up being negative. And then for our last example, we're given a trig function this time, and then the fact that it is in quadrant 4, which I didn't do this on purpose, they just all ended up in quadrant 4. But since they tell us what quadrant it's in, we can go ahead and set it up. We've got our theta. If we know that the cosecant of theta is -2, remember that it is the reciprocal of sine. So if sine is the opposite over hypotenuse, cosecant is hypotenuse over opposite. So that means that my -2 over 1 is going to be talking about the hypotenuse and then also the opposite, so that 2 and 1. Remember that the negative could apply to either part of this. So just because I had a -2 doesn't mean that the hypotenuse is negative, because remember our hypotenuse is not negative. But that negative could apply to the denominator, which it does, because that y value would have to be negative in the 4th quadrant. We do know that our x value here is going to be positive, but we do need to find it because cotangent is going to involve that x value. So using our Pythagorean theorem, we've got our -1 squared, and it really doesn't matter that it's negative or positive. And we're going to end up with our missing side there being radical 3. Remember when we're solving here that we end up with a positive or a negative because we decided to take the radical of both sides, but then we have to use the context of the problem. Because of what we're talking about here, it does have to be the positive version because we're in the fourth quadrant. So now to find cotangent of theta, just like cosecant, I'm going to kind of think about it backwards, that my tangent would be opposite over adjacent. So if I'm trying to find cotangent, then I'm going to have adjacent over opposite. So for my cotangent of theta, I'm going to end up with a radical 3 over a negative 1, or just a negative radical 3. And definitely if it helps you to go ahead and say, okay, tangent of theta is negative 1 over radical 3, and then take the reciprocal of that, I think that could be a helpful way to write out what you're thinking. So I've got one more type of question for this lesson, and we've answered something kind of similar to this before, but we've figured out an angle for that ratio that was in the first quadrant. So for this one, we're actually going to be finding two solutions, and instead of giving us that 0 to 90 degrees and the 0 to pi over 2, they're going to tell us really one full unit circle. So anywhere from 0 to 360, 0 to 2 pi. So all the way around the circle. That's why we're going to have two solutions, because if something is positive, that means that there are two different places where it's positive. If it's negative, there are going to be two different quadrants where it's negative. So again, important to know what quadrants are going to give us positive, negative for sine and cosine at least. So starting with the cosine of x equals 1/2. So first, just because it's positive, I'm going to go with the fact that my x value is positive to tell me that this x is going to be happening in the first quadrant and also in the fourth quadrant. So I'm just thinking through the fact that in the first quadrant x is positive and the fourth quadrant x is also positive. So this is where it should be happening. From here, I've got to rely on my memorized first quadrant. Cosine of theta is equal 1/2, and I would need to know that that happens at pi over 3 or 60 degrees. So if I want to go ahead and put 60 degrees right here, remember that I'm staying in between 0 and 360, so I'm not allowed to say that this angle is negative 60 degrees, but I can go the other way around, and I want to stop at that terminal side. So I'm going to have a 60 degree angle, and then this other angle, if I start at 0 and go all the way around but stop at 60, that means I've traveled 300 degrees because I'm still 60 degrees from 360. So 60 and 300 would be in degrees. And then for our radians, I would have to know that 60 degrees is pi over 3. And then in order to be in the fourth quadrant, I'm going to have to be talking about still something pi over 3, but I can't have it be 6 pi over 3, so it's going to be one less than that. So 5 pi over 3 would be in the fourth quadrant. And if it helps you to kind of go through each one of them, you've got your pi over 3 in the first quadrant, 2 pi over 3 is in the second quadrant, 3 pi over 3 is just pi, we've got 4 pi over 3 in the third quadrant, 5 pi over 3 is in the fourth, and then 6 pi over 3 is at the x-axis again. So there we are. But knowing the fact that cosine of pi over 3 is 1/2, that's a big deal here. We don't want to have to look at the unit circle every single time for something like that. Okay, so same question here, but talking about tangent of x equaling 1. Again, first I want to decide what quadrant this has to be in. If my tangent value is positive, that means that when I divided sine over cosine, that either both of them were positive or both of them were negative. So my two different quadrants that could happen in, if they're both positive, then it would be happening in the first quadrant. If they're both negative, then that would be the third quadrant. That's our two different places we're talking about. And then again, this is one that I would kind of have to have memorized, that if my sine over cosine is ending up being 1, that means that they were the same value. And we know that that happens at 45 degrees because sine and cosine are both radical 2 over 2. So we'd have a 45 degree angle here, 45 degree reference angle for the other one, but we're going to need to figure out what that is. So we've got 45 degrees. And then to figure out this one, we are at 180, and then we went another 45 degrees from 180. So this would be at 225. So there's both of my degrees for this. If I'm talking radians, my 45 degrees is pi over 4 radians. And then to figure out in that third quadrant, that means that I'm greater than 4 pi over 4, because that would be pi. So one more than that is going to be 5 pi over 4. There we are. So in general, this is a more typical question that we would see at the end of like a calculus problem. This is a really big deal, that we can get to this point and be able to think through the two places where it's positive, for this one, the two places where it was positive, and then know our reference angles and the unit circle well enough to do this without a calculator or looking at anything.